Okay, we're going to try to make these shorter today. So today we're going to be solving compound inequalities. And so what that can mean is one of two things. You're either going to be given two separate inequalities to solve, and if those two separate inequalities to solve use the word or in between them, then what you're going to do is you're going to solve each of the two inequalities, and then your solution set is going to be the set that makes either one of them true. So remember that word or means that one of them can be true or the other one of them can be true and you'll still be okay. So that's the first situation. The second situation is actually just like a little offshoot of it. We're still going to be solving two separate inequalities, but they're going to have the word and in between them. So that's technically one situation. So here's the first example of that first situation. We've got two linear inequalities, and we've got the word or in between them. Okay, and that's really not going to matter to us until actually after we've solved the two inequalities. So on this first inequality over here, I can go a couple of different routes. I could distribute through there, but that's the step I'm actually going to have to kind of counteract and backtrack in just a minute, so I'm not going to bother with that. I am going to divide both sides by -3 instead. Now, first of all, it's going to cancel the -3 off the left side, but the one reminder is that when you solve an inequality, which I think must have been on yesterday's notes, when you multiply or divide by a negative, this inequality symbol right here is going to flip. So what that means is that I've gotten rid of the -3 on the left side, but now that symbol is going to be a less than symbol. And then that 15 divided by -3 is -5. And then, of course, my last step would be to subtract the 2 to move it over. And so that's what I get for my first inequality. Keeping in mind, of course, there's the word or in between them. And then the second inequality is even easier. I'm just going to add 3 to move it to the right side, gets rid of the 3 over here. And so x is less than or equal to 2. Okay, so what that means is that any number that makes one of those two inequalities true is a solution. Okay, so what I look at, I'm going to change my color here. My first inequality said that x was going to be less than -7. So I'm going to I'm just going to make this like -7 down here. -6, -5, -4, -3, -2. So that would put 0 right there, and it would put 2 right there. Okay, so everything fits. So less than -7 means that I can put parentheses here, or I can put a hole here, however you want to draw that. And everything to the left of it would be a solution. Okay, and then this inequality over here, it's not a very good color to draw in. Let's see if this shows up better. Okay, there we go. That inequality over there says that any number that is 2 or less would be a solution. So I put a solid dot at 2, or I could put a square bracket, and everything to the left of that would be in the solution set. So what that means is that anything that's in that green area is going to be a solution, because it's either going to make the second inequality true, or it's going to make the first inequality true. Even -7 would be a solution, because -7 wouldn't make this one true, but it would make this one true. -7 is less than or equal to 2. Okay? On the next little subset, it's the same situation. We're going to have two separate inequalities, but this time they're going to have the word and in between them. So what that means is that we have to have both inequalities being true to have our solution set. Okay, if there's no overlap, then we've got the empty set, which remember is just that set brackets with nothing in it. Okay, so you can have no solution to these things. Okay, so the example for this one, same process. I have two linear inequalities to solve. I'm actually going to go ahead and solve the one on the right first because it's the simpler one. So I'm just going to divide by -3 to solve it. gets rid of the negative 3 there. And then keep in mind that I just divided by a negative, so that inequality symbol right there is going to flip, and it's going to become greater than. And then negative 2 divided by negative 3 is 2/3. Okay, so there's the solution to that inequality. Now the second inequality, I can do a variety of things. Okay, what I'm going to do first is I'm going to go ahead and add the 5/6 to move it over. I didn't have to do that as my first step, but that's just what I chose to do. Okay, and then I can get rid of the fraction by multiplying by its reciprocal, or you can do it as a multiple step problem. If you want to get rid of this dividing by 3 down here, then you can multiply the whole thing through by 3, and then you could divide by 2. I mean, you can do it as multiple steps or one step or however you want to do it. You could even multiply through by 6 to just get rid of all the fractions, if that's what you would prefer to do. I'm going to multiply by 3/2, because when I do that, when I multiply to that left side, it gets rid of the 2/3 and leaves x by itself. And when I multiply over here, 3 times 5 on top is 15, and 2 times 6 on bottom is 12. And then even better yet, I don't have to do this, but I can reduce my answer. 15 over 12 reduces. A 3 comes out of both numbers, and so I get this solution. So I get this inequality right here, and the word "and" is in between them. And then I got that solution there. So what I'm going to do is I'm going to graph them both on my number line, but then I need the answers that make both true. So what I'm looking for is the area of overlap. Where did the two solution sets overlap each other? So on my number line, my numbers are pretty small. I've got 2/3 and 1 1/4. So I'm going to go ahead and I guess I'm going to put, maybe 0 here. And I don't have to scale it in integers. Let's say that I wanted to do 1, 2, 3. Let's say I made this 1. So this was 0.5. So then 1, 2, 3, 4. So this is -1. And this is -0.5. So now I can fit everything a little bit better, but once again, that's up to you. We weren't told how we had to scale our number line. So here's my area of overlap. Here's my first solution. 5/4, like I said, is 1 1/4. So that would be right here. And I'm going to put a solid dot because it had that equal sign. And it's less than, so I'm going to shade everything to the left. Okay, now I need the area for this one right here. So x is 2/3, which is, 0.6 repeating. So I'm going to put it right about there. I'm going to label it 2/3 because otherwise I won't have any clue what it's representing. But it's going to have a hole because it was strictly greater than. And I'm going to shade to the right, which will be everything to the right. And then what I do is I look for that area of overlap. What area will have the solutions that work for both inequalities? And that's this area right here. Okay, and so that is my area of overlap. And I could even write it as a single 3-part inequality, which is actually the second situation we're going to see. My solutions are all in between 2/3, and 5/4. So I can write it as a single 3-part compound inequality. But that's up to you. You weren't told you had to. If you don't, you do have to write the word "and." Otherwise, it's not there. And we can explain why it's not there if you want to know later. Okay? So when you have a compound inequality that is written as one statement, which means a 3-part inequality, then you're going to follow all the same steps. The only thing that really changes is this right here. Anything you do to the middle of your inequality to get your variable by itself, you have to do to both of the other sides, not just one other side. Okay? And of course that means that if you multiply or divide by a negative, you've got to flip both inequality symbols. So if I look at this one right here, okay, nice easy numbers, no messy fractions or anything like that. I want to get x by itself, and so I'm going to add the 4 first. Well, that means I have to add 4 to all 3 parts. I have to keep this balanced all the time. And it gets rid of that, and I have 6 is less than 3x is less than or equal to 23. And then I divide everything by 3. And so I have 2 is less than x is less than or equal to 23/3. Which if you want to, you could have written that as 7 2/3 if you want to know where on the number line it would fall. Okay, so what that means is that your solutions have to be in between 2 and 7 2/3. So I'm going to make sure that I have room for that. So I'm going to put my 0 way down here. So here's 2, here's 4, 6, 8. Okay, and I'm going to draw this part first. So I put a hole there at 2. And then this part. So at 7 2/3, I'm going to put a solid dot. So here's 7 2/3 would be right about there. And so I'm going to write that 7 2/3. And I put a solid dot there. And because x has to be in between those things, I shade everything in between. Right there, like that. And there's my solution set. Okay? So I want you guys to take a second and I want you to practice this one. This is a linear equation with decimals in it, so you're going to treat it like the linear equations with decimals we did before. So just pause it for a split second, try this one out, and then we'll see how you guys did. Okay, hopefully you paused it. Hopefully you gave it a shot. I am going to go ahead and the first thing I'm going to do is I'm going to take the whole thing and multiply through by 10. I want to get rid of my decimals. Okay, so I distribute to there, and I get negative 82. Less than, distribute to there and get 14. Distribute to there and get minus 10x. And distribute to there and get negative 9. Okay, so now I can more easily solve it. So I'm going to go ahead and subtract 14 from all 3 parts. Like that, it gets rid of the 14 here. So I have negative 10x in the middle. I have negative 96 there. And I have negative 23 there. And then I divide everything by negative 10. Now, of course, remember, when you multiply or divide by a negative, the inequality flips. So that's going to be true now of both inequalities. Both of those arrows are going to flip, not a very good arrow, because of the dividing by the negative 10. So this would give me 9.6. This became the greater than symbol. I've got x by itself, and then this is 2.3. Okay. Now, if you forget to flip the inequality symbol, it's not going to be devastating. Theoretically, you should catch yourself, because if you forget to flip the inequality, this is what you would end up with. And you would look at that, and hopefully you would understand that doesn't make sense. X can't be bigger than 9.6 and smaller than 2.3. There's no way to fall in that area. There is no area where you're bigger than 9.6 and also smaller than 2.3. So theoretically, you would catch yourself if you forget to flip those inequalities. And then we would graph that. So I'm going to put 0, here's 2, 4, 6, 8, and 10. Okay, and so 9.6, let me change colors again. 9.6 would fall right about there. And 2.3 would fall right about there. And I'm going to use holes at both of them because it was strictly greater than or less than. And then I'm going to shade everything in between. Okay? And that's it for solving compound inequalities. So nice short 15-minute notes today. Remember, you guys have to be watching the notes for this to do any good. So I know I'm preaching to the choir. If you heard me say that, you just finished watching one of my videos. But otherwise, we'll have to go back to doing notes in class if people aren't going to watch these. See you guys tomorrow.